Hello everyone, my name is Ritu Favre and I'm the Executive Vice President and General Manager of NI's Semiconductor and Electronics, Transportation, and Aerospace, Defense, and Government Business Units at NI. I am honored to be a part of this year's SemiCon Korea Test Forum. Today, I am particularly excited to talk about a new vision of reimagining the engineering workflow to help you keep up with the pace of change in the industry. Korea has historically been at the forefront of deploying new emerging technologies. From the world's first commercially available MP3 player to the first completely touchscreen phone, Korean engineering organizations have earned a reputation for their disruptive innovations in the industry. Even today, as 5G research continues, Korea has established itself as one of its main testing grounds. What's more, Korea is expected to be one of the first markets to see fully functional 5G deployments. As wireless technology research continues, Korea is also positioned to see similar 6G deployments sooner than the rest of the world. However, as the rate of innovation continues to increase, even Korean semiconductor companies are vulnerable to global disruption. The growth in the Korean semiconductor market is tightly linked with many of the macro trends that are shaping this industry. Not only does each new technology create business opportunities for companies to take share in new markets, but it also changes the way that engineers design and test these products. From 5G to mobility to digital transformation, these inflections ultimately drive faster development timelines and increasingly motivate a software-centric approach to product design. In my 30-plus years in the industry, time to market has always been the major concern for every project. However, there is no question that the pace of technical innovation is accelerating. With the rate of engineering happening more quickly than ever, engineers are forced to accelerate every phase of product development. We see this consistently in our industry, from the cost of being late to market to the race to be first. One of the most prominent examples is the race to smaller process technology nodes. Recently, both Samsung and TSMC began volume production of 5-nanometer chips. Today, foundries are vying to leapfrog one another with 3-nanometer and even 2-nanometer process technology. Recently, IBM announced that it has produced the world's first 2-nanometer node chips, promising energy savings of up to 75% versus today's technology. 6G is another great example of both accelerating product timelines and new technical requirements. The idea that engineers are working on 6G might sound crazy to you, especially as we're in the early phases of 5G deployments. However, each generation of wireless technology can take more than a decade to create. Today, researchers are already working to define what is next after 5G, or what is referred to as beyond 5G. It probably won't surprise you that companies are looking to accelerate 6G with promises of first deployments by 2028. We know that the early players will have a unique competitive advantage, and this drives the need to be first. With an increasing need to be first, streamlining the engineering workflow has become more important than ever. Inefficiencies in design and test can have a significant impact on release dates. In parallel, with the intense pressure to be first, engineering teams must also cope with the fact that each new design is more complex than the one before it. For example, in keeping up with the wireless theme, consider the progression and the complexity of a relatively simple RF front-end module. When characterizing a 4G RF front-end module 10 years ago, one might have to deal with less than 100 test cases, each with a different combination of radio band, carrier bandwidth, and waveform type. Moving to a 5G front-end module, the number of test cases has increased by almost 10x. However, engineering product schedules don't allow for a 10x increase in validation or characterization time. If anything, the expectation is even faster development. As a result, engineering teams are constantly pressured to develop faster and more efficient test methodologies. In addition to the need to do more measurements, the measurements themselves are actually becoming more complex. For 5G millimeter wave devices, the adoption of antenna-in-package technology means that there is no longer a physical connection to access the millimeter wave signal. As a result, many 5G millimeter wave devices require over-the-air testing, which is a completely new test methodology. Another example is modern optoelectronic products. VCSELs, or vertical cavity surface emitting lasers, are increasingly used for 3D sensing applications. With these devices, the desire to limit heat dissipation and power consumption at high peak powers is driving the need to operate VCSELs for extremely short bursts of time. Pulsing is an important innovation driving adoption on power-conscious applications such as facial recognition on smartphones. Finally, the acceleration of the MEMS market is sourcing a myriad of test and measurement innovations. Some of the most interesting MEMS measurements are for inertial sensing devices. Testing these devices requires physical movement of the device under test in parallel with measurement of electrical signals, which often requires changes in the approach of most test labs. In many ways, the design validation and test engineers that we work with are often caught in the middle of the competing priorities of their organization. These teams must balance cost and complexity with faster time to revenue expectations. In fact, engineers are being tasked with developing more complex devices in less time and at lower cost than ever before. Since doubling or tripling test capacity is not a viable choice, engineers are forced to be more efficient with the resources that they have. From my experience running several semiconductor businesses, the scarcity of the capital equipment budget is magnified at offshore locations. In many cases, the further a lab is from corporate, the fewer resources they tend to get. This reality elevates the importance of automation software in the lab. These tools are some of the most effective techniques to stretch test equipment budgets as far as possible. I believe one reality that is both a challenge and an opportunity is the disjointed nature of many large organizations. Natural silos between various R&D teams and off-site locations often create a duplication of effort. This is especially true in large semiconductor companies. The engineers that I talk to in the characterization labs tell me about new designs getting thrown over the wall with little collaboration on test requirements and methodology from the teams upstream. This issue is compounded by the fact that many semiconductor organizations have grown through mergers and acquisitions. This creates duplicate organizational structures with multiple teams solving the same challenges. However, not sharing best practices or communicating with one another creates inefficiencies and represents a significant missed opportunity. Obviously, some duplication is always going to happen, but I see many companies benefiting from increasingly sharing both test software and test methodologies across their sites. In fact, some of the most successful organizations that we work with have driven efficiency by standardizing test measurement software globally. In our interactions with engineering labs across the world, we have seen that companies who adopt a common software framework ultimately reduce their engineering costs and accelerate design schedules. When you take a detailed look at the workflow of a product characterization lab, simply pulling instruments out of a closet and manually configuring them by hand is one way to characterize a semiconductor device. However, we have observed that organizations that first automate their measurements and then standardize on test automation software in the lab are much more efficient. Standardized software enables quicker device characterization and often results in an ability to expand measurement coverage. And this is true regardless of which software engineering teams adopt. Many of our customers have done this successfully using a wide range of languages, from Python and C+ to LabVIEW. Within the next decade, data analytics software will also play an increasing role in our product development workflows. Today, we already observe the challenges associated with correlating simulation results from the design process to the measurement results in the characterization lab. Effective use of data management and analytics tools is an important aspect of modernizing the lab. Sharing data across sites and teams is an important step to improving overall organizational efficiency. I know that the idea of modernizing your lab may feel overwhelming. In addition to new skill sets and techniques, any change can introduce inherent risk. Moving to a modernized lab approach often happens in small steps. depending on the risk tolerance and technical capabilities of the organization. One of the things that I want to leave you with is that even small changes like deciding to automate measurements can have a big impact. Automation drives faster device characterization and produces invaluable measurement data. Our customers often tell us that they can characterize first silicon devices coming back from the fab anywhere from 5x to 10x faster, simply by transitioning from manual to automated measurements. We have also found that once customers start automating measurements, they tend to also increase the number of measurements. As a result, they end up with more data to help them better understand the behavior of their devices. To give you an example of the scale of benefit we typically see when adopting modern approaches to characterization, I wanted to share some of the results from an example of a major semiconductor company. We conducted an in-depth study of a top-tier semiconductor customer to help them understand the true impact of investing in both hardware and software standardization. We found that our customer saw a 40% reduction in hardware cost. They also saw a 2x improvement in test coverage with the same or less time. All of this started through effectively automating measurements in the lab. We have talked about automation often being the first step our customers take to modernize their labs. In many instances, the second step is the adoption of a standardized software framework. As I have mentioned before, software can improve productivity, but to do so, it must scale. Even relatively simple devices like ADCs or LDOs require some degree of instrument synchronization. This means that performing simple measurements requires at least basic test automation software. Although someone must initially write software, sharing code across teams and sites can reduce duplication of effort. This helps other teams get a jump start on product characterization. One of the things best-in-class organizations do effectively is centralize the development, maintenance, and distribution of automated test software. At NI, our goal is for engineers to leverage off-the-shelf software to make this process easier. We're innovating on a workflow that leverages common IP and measurement software in both interactive and automated measurement environments. Our aim is to enable engineers to quickly bring up a device using device-specific and configuration-based measurement panels. Once the measurement has been configured, you simply save settings to a configuration file. Later, when doing automated characterization, you simply point to the same config file in the automated measurement environment, and all of this is without having to do a single bit of programming. This framework helps engineers maximize measurement IP reuse and reduce setup time. Our vision is to continue making it easier for our customers to standardize on measurement software. What's more, standardized software also enables consistency in data capture. This consistency helps lay the foundation for smarter product data analytics. By now, you have heard me make several references about how data analytics is the next frontier for test. Each step in the product development process generates mountains of data, and it is often difficult to make use of it all. I see a sizable opportunity in helping our customers to create deeper product insights by connecting data gathered during different phases of the workflow. While a common software framework can help speed up the sourcing of consistent data, product analytics solutions can generate actionable insights. Consistent with the need to accelerate product development, data management and analytics tools provide a unique opportunity to improve productivity. Today, each stage of design produces immense amounts of data. That data is often poorly managed and insufficiently leveraged throughout the design process. If you have ever tried to compare simulation data with measurement results for a device, you likely know firsthand that it can be extremely difficult to know whether the two data sets were generated using the same settings. In addition, this challenge becomes even more difficult when generating hundreds of thousands of data sets from a single product in the characterization lab. Comparing all of these sets of data against the specification for the device through its entire life cycle is virtually impossible today. As product complexity escalates with each generation, data management and analytics tools will become an increasingly critical aspect of the semiconductor design workflow. Fortunately, we are seeing rapid innovation in analytics technologies like artificial intelligence and machine learning. As a result, I believe that engineers will heavily rely on these tools to accelerate their product development. The rising demand for increasing connectivity continues to shorten product development significantly. I believe that as AI and cloud computing markets evolve, Korean semiconductor companies will embrace new approaches to achieve their tight market schedules. That is exactly why I'm excited to be here today, because there is a massive opportunity for Korea to once again pave the way for innovation. For those of you that work in a lab environment, I would like to encourage you to start thinking about what modernizing the lab could mean for your team. We know that any change comes with risk, but we also know there can be a massive payoff. We're committed to helping you through a combination of products, services, and people. Thank you so much for having me here today. I encourage you to continue to engineer ambitiously and continue to be a leader in your organization.